X and Y intercepts. Take a look at example 1 there, y equals 2 to the x power. Now, you've got some background knowledge about exponential functions, and they all look like this if they're exponential growth, and they look like this if they're exponential decay. No matter which one you're facing, an exponential function, unless it's being shifted up, down, left, or right, generally speaking, anything to the x power has a horizontal asymptote at 0, so it's never, ever, ever going to touch the x-axis. Therefore, it has no x-intercepts. The y-intercept, remember we did a whole bunch of these, and the y-intercept is always 1. Now, one way to look at that was the y equals ab to the x power, and remember we said the y-intercept was at 0a, or in this case at 0, 1, because the number in front of 2 here would be a 1. So that's where that comes from. The log of x, same idea. You got some background knowledge. It's the inverse of the exponential function, so it also is going to cross right here at 1. And your y-intercept is where the asymptote lies, so it is not going to have a y-intercept. As far as the quadratic here, for example 3 goes, it's always a good idea. Anytime something says f of x equals or y equals, that is an invitation for you to go ahead and graph it and see what you're dealing with. X-intercepts here, when you look at the graph, it might not always be obvious if it was a decimal. This one, it's pretty clear that it crosses at -2 and 2, so that would at least give you a good starting place. Mathematically, in order to find the x-intercepts, we've got at the top there. To find your x-intercepts, you're going to plug a 0 in for y. Remember, f of x is the same as y. So if I plug a 0 in for my y, it looks like this. When I go to solve this one, it looks like a difference of perfect squares. So I'm going to have x plus 2, x minus 2. And that's going to yield 2 solutions, -2 and 2, which is what we suspected. Mathematically, to find a y-intercept, you can plug a 0 in for x. So I go with my original, put a 0 wherever there was an x. And I can see my y-intercept at -4. That's confirmed right here by my graph as well. The last one here, an x-intercept, well, we can tell that crosses at the origin. So I see an x-intercept at 0, as well as a y-intercept. It looks to me like right here, we've got an asymptote. So you can kind of tell along this line. Oh no. That we have an asymptote somewhere maybe right along here. Oh dear, this isn't going well. Go back, little graph. Don't you worry, I got this under control. Okay, all right, onward. X-intercept, y-intercept. So let's do it mathematically as well and confirm what we think from the graph. So I'm going to plug in a 0 for y. Well, I have to get rid of divided by x plus 2. So when I multiply both sides by x plus 2, I get 0 equals x. And that's what we noticed in the graph. It crosses at the origin. The y-intercept, I'm going to plug a 0 in for x, which gives me 0 over 2, and 0 divided by anything is just 0, confirming what we see in the graph.